Hi guys, I'm going to work through one of the practice problems off of practice quiz 8B. So in this problem we're given a competitive firm and they have this cost function and this marginal cost function. And the problem tells us what the profit maximizing level of output is and what the firm's profit would be there. So what we're asked is if instead of being interested in maximizing profit, if this firm was interested in maximizing profit per unit, how much would it produce? So it's not told to us why the firm is interested in maximizing profit per unit, but suppose that they are, we just need to find what quantity would do that. So here's how we're going to think about that. So our definition of profit is that it's equal to the firm's total revenue minus the firm's total costs. So if we're instead interested in profit per unit, profit per unit would be profit divided by quantity. So then that would be equal to total revenue divided by Q minus total costs divided by Q. So total revenue for our perfectly competitive firm is just price times quantity. Right? Total revenue is the price they can charge for each good times the number of units they sell. And we have total revenue divided by quantity minus total cost divided by quantity so these Q's cancel, we're left with just P minus, and total cost divided by quantity by definition is equal to average total costs. So profit per unit is equal to price minus average total cost. And so for this firm, we're trying to figure out what quantity would maximize this. So the first thing we notice is that this P, this whole portion of it here, doesn't depend on Q at all, right? This is just a P, it's just a price, which in this problem we're told is 75. So the thing that is going to vary depending on what Q we choose is this ATC term. And since we have price minus ATC and we want to maximize this whole thing, what we need to do is find the Q that's going to minimize average total cost. And what that looks like in a graph is we have our average total costs that are shaped like this, and our marginal costs that are shaped like this. And we want to find the Q that's going to minimize average total cost, and that's always going to be at this point right here where marginal cost intersects average total cost. So whatever that Q is, that's the one that we're interested in. So in our problem, we're given the firm's total cost function, and we're given the firm's marginal cost function. So the first thing we need to do now is just find what the firm's average total costs are. So average total costs are equal to total costs, our C function, divided by Q, which in this case comes out to 0.64 Q plus 25 plus 1600 divided by Q. And we're looking for this point here, this Q, so we want to know where that average total cost intersects marginal cost. So we're just going to set those two equations equal. MC equals ATC. Our MC in this problem is 1.28Q plus 25 we set that equal to our ATC that we just found of 0.64 Q plus 25 plus 1600 over Q. And now we just solve this for Q. So we see on both sides of the equation we have a 25, those cancel. I'll subtract 0.64 Q from both sides, leaving me with 0.64 Q over here. And that's equal to our 1600 divided by Q. So now I'll multiply both sides by Q and get Q squared over here, divide both sides by 0.64 and get 2500 over here, which tells us that Q is equal to square root of 2500, which is 50. And that's our answer. That's the number of units the firm would produce if it wanted to maximize profit per unit. And then the last part of the problem just asks us, at that quantity, what would their profit be? And to find that, we just take our profit, which is equal to price times quantity. The price given in the problem is 75. Times our Q of 50 minus, and we want our total cost, which is 0.64 times Q, which is 50, plus 25Q. Again, our Q, sorry, that's 50 squared here, plus 25 times Q, which is 50, plus 1600. All right. So that's our profit. And if we just crunch those numbers, we come out with a profit of negative 700. And that's our answer here.